Hi, I'm Eric Zawalko from Facebook. I'm a media systems engineer there, which is a confusing title. What I do is work on our internal corporate live product for company communications, as well as design and produce our high-profile external-facing live streams for our executive team.
Cool. Yeah, my name is James Broberg. I'm CEO and founder of Streamshark. We were formerly known as MetaCDN. So my background is on a bit of background on traditional CDNs. A lot of our early work was around aggregating and optimizing content delivery networks, but more recently, all our initiatives are under the Streamshark umbrella, working on VOD and live streaming workflows. Just super passionate about live streaming workflows and reliably executing live streaming events, which is what we're talking about today.
Yeah, so if you don't live stream big events, you're probably in the wrong room. But all right, so what things should you sort of think about? What are the best practices for executing high-profile live streams? And the first lesson of live streaming is don't. Most of the content that you're going to be asked to live stream is not really worth it, and live streaming has a really high risk factor. Anything that you do on a live stream, any problems that you have, any equipment that fails, it's going to be visible to every single person who watches the event. So going live is terrifying. Like, it is the scary, pressing the button that takes you from like your preview state to, oh, people are starting to watch this now, is the scariest moment of my life every single time I do it. And it is really, really terrifying. And if you don't feel that way about it, there's probably one of two things going on. Either one, your content isn't high enough profile to warrant the cost of these high-profile live streams and the complicated systems you have to set up to do them reliably, or B, you don't know what you're doing, and it's a good thing you're here then, because we're going to talk about that. So one of the things that I like to say is that there are four good reasons to live stream that make this rule not count. The first is sports, live sports, breaking news, interactivity, and the last one is kind of a new one. It's like, we've been calling it sort of like the watermelon stream, which is like when BuzzFeed did the watermelon and putting the rubber bands around it and you wait for it to explode. I don't know if any of you guys saw it. It got a ton of views on Facebook Live. It was really fun. I watched it for like I know what happens at the end of that. The watermelon explodes. I watched it for like 35 minutes. So that's the other one that I think is a good reason. But one of the things we're seeing a lot these days is because now there are all these free platforms to go live on, whether it's YouTube or Facebook or Periscope or Meerkat or whatever, people think that live streaming is now cheap and easy. And that's true if you're like in your backyard having a barbecue and you want to go live to your friends. But it's not true if you're doing high profile, sort of can't fail, if this messes up, I need to go look for a job tomorrow type of events. Those are still almost just as expensive as they have always been and just as hard and high risk as they have always been. And so this is sort of when we set up a live stream, this is what it looks like. So we have on the left side, all of our production equipment, so like some of the stuff you see in the back. That's the cameras, the microphones, the video switcher, any effects you want to do, any delay systems you'll have. Transport, which is one of the harder ones. That's something like satellite trucks, fiber backhauls, bonded, cellular solutions like a LiveView or a Teradek Bond or something like that. Then you have your encoding, and then ingest and delivery and your player at the end. This is sort of a simplified version. It actually is a little bit more complicated than that. We have, you see here, we've added a few more steps. I'm going to sort of go through the first half, and then James is going to talk about the second half of these steps. So end-to-end signal flow, when we're talking about in the room, we're going to talk about the camera switcher, the production, the audio, all that stuff. I mean, you can read what we're going to talk about. I'm just going to go into it. So let's talk about all the things that can go wrong when you're going live. The first is everything in production. So your cameras can fail, your switcher can fail, your audio. So like both James and I have worked on a lot of live events, and if any of you have too, like this stuff fails every time. Whether it's like someone on a production crew you've never worked with before starting to change audio patching as you're going live and suddenly you lose all audio, which happened somewhat recently for us. Or it can even be like a bad patch bay that has never, we had an event happen where we had a patch panel that was inverting the phase on one of our audio channels. So it was fine when you listen to it on headphones, but if you listen to it on a mobile device with a single mono speaker, you got no audio.
Yeah, perfectly downmixed and canceled. Yeah.
Completely canceled out, which is like, how do you catch that in testing? Like, that's one of the things about live streaming is you like test and test and test and test. And this, like, sometimes you're just gonna have these issues that are like almost impossible. And also, if you've ever been to an event that they're live streaming and you've seen the production setups, like these guys, these production crews have like sometimes less than 24 hours to get in the space, build a stage, do all the rigging, set up all the equipment, do all the testing, and what you end up with is something that looks like this. And it's like, if that's something that you feel comfortable trusting, like that, and it's what you have to do because of the time constraints and everything, but one of the things that becomes really important is have a backup for everything. I would rather use two sort of cheap video switchers than one like $30,000 one, just because it's much more reliable to have two of everything than one of really nice stuff, if you can do it. If you can only get one, like use really nice stuff though, because the cheap stuff fails sometimes. Next, we're going to talk about contribution and uplink, which is like our on-site connectivity, how we get the signal from the room, from this room, into our live streaming platform. This is like one of the hardest ones. This is where redundancy becomes most important. And there's a lot of solutions out there and a lot of different encoders and a lot of different uplinking solutions. And it's really important to have a good understanding of how they all work and like what is going to be reliable for you. In every situation, I like have at least two paths because one of them is going to fail, and they do regularly. So like, we always like to use satellite trucks for our really high profile stuff. This is something that I've seen a lot of recently with some events is there will be an event that a broadcast news network is coming out to cover, and they'll bring their satellite trucks that are beaming signal back to their like big data centers that have like bays and bays and bays of $10,000 encoders, and they're using that for their TV broadcast. But then they send a social media manager out with a laptop running OBS to do their live stream. And it's like, why? Why would you do that? Like, use the good stuff. You already have it out there. But that's sort of one of the things that, like, there are all these great solutions like OBS or Wirecast that are kind of lower cost things, and they're great for a lot of things. But if the president is getting up to do a press conference, like, please get a satellite truck or a fiber backhaul or a bonded internet solution or something like that, and use all of them. Get all of those things.
Yeah, we will. Yeah.
This whole talk is being recorded, so the slideshow will definitely be there. We can probably post.
Yeah, we can post it.
Yeah, or we can email it to you, I guess, if you want it. Yeah, having diverse signal paths. Like, this is the sort of thing where like there's so many things that could go wrong here, from like your fiber cable getting cut if someone's doing like street maintenance somewhat close by. Bad weather affects satellites and you start getting rain fade. if you're using a bonded cellular solution at something popular, like as soon as you get 10,000 people all converging on a single place, your network conditions just change drastically. So having a lot of options and having them all ready to deploy during the entire live stream, like before it, testing them all for several hours beforehand, having them ready to go, and then if something goes wrong, even if it's in the middle of a stream, like I've had this happen where we were in California, we were using a satellite uplink to a encoding facility that we had in Washington, D.C., and all of a sudden it started raining really hard in Washington, D.C., and we had to fail over to one of our backup solutions without anybody noticing. I think we failed over to a live view or something like that. But yeah, so it's be ready to switch at any time, be monitoring all of your connections wherever they're going, and then also use good hardware encoders. Don't rely on, don't bring a laptop with OBS and expect the network at your facility to work, because once you get 10,000 people in there, or 50,000 people, or 100,000 people, or 500 people even, like that network is going to change. And even if the on-site network guys say like, hey, we have dedicated bandwidth for you, you probably don't. They're probably just telling you that because they've never had an issue before, but you're going to have that issue because when you're live streaming, everything goes wrong for you. I think that's everything I have on that slide. Oh yeah, and don't use a phone. Like, there's a lot of great phone apps for doing live streaming, and once again, great for your backyard. Don't use it for these high-profile events. It's so much better if you have a room with cameras and a production crew and these great AV guys who work hard to make this look and sound really good. Like, use their signal. It's going to look better. It's going to be a better experience for everyone.
All right. Okay, now into the area of my responsibility. So yeah, now we've got this fantastic contribution signal. Let's look at the rest of the workflow here. So at a minimum, I think we really want to be using both a primary and a backup ingest, because if you're just running a single ingest, let's say you're running it in the cloud somewhere on Google Compute or EC2, and there's an outage in that region or that availability zone, you're going to be in a lot of trouble. You've got no live stream. So at a minimum, we'd really want a primary and a backup ingest, preferably running in different AZs, availability zones, or better yet, totally different geographical regions, just to reduce the probability of failure here. Better yet, as we spoke, as well as having those primary and backup ingest, want them being fed by those distinct signal paths that Eric just spoke about. So ideally, we'd have our primary being fed by the SAT truck heading up to the satellite back down to the data center, and then a short push over IP to our primary, and then our backup perhaps being serviced exclusively over IP with a bonded connection, pulling in cellular, bonded internet, as well as the on-site or whatever else you can cobble together at the venue. That's then unpacked and pushed to our backup ingest. So that's really maximizing your chance of success by having those redundant paths, having those redundant ingests where we can fail over to a different feed in the event of a major issue. As well as having the primary and the backup, we may wish to want to load balance between the primary or the backup, or fail over in the event of a major issue on our primary. And we want to do that in a totally seamless and stateless way. So to do that, we really need those two signals that are coming in over those redundant paths to be as identical as humanly possible. So ideally, they're going to be timecode aligned, they're going to be keyframe aligned. So in the event that we need to switch from a DNS load balancer or an application layer level load balancer, or even at the client, switching between those two feeds, we want that to be as seamless as possible, so there's no breakup, no jumps, no change in time or anything like that. So that's fairly essential to make this a totally seamless experience. So a little bit tricky to do, a bit tricky to set up on the encode pipeline, but it's definitely possible and well worth your while. In terms of transcoding, of course, we're just going to put it in the usual formats that I'm sure most of you have dealt with. We'll transcode and packetize out to HLS, which is great for our mobile clients on iOS and Android, because we've got that fantastic native support for those mobile platforms for that standard in both the browser and the operating system. On desktop, we probably tend to favor Dash just because we have those nice media MSC-based pipelines and nice playback engines for dash playback, which can generally deliver a higher quality experience on desktop. So, of course, we're all fussy about quality. We want to push the highest possible quality for our streams, but let's not forget about the guys on low bandwidth connections or marginal connections, perhaps a cellular connection that has a very low throughput. So for those guys, we definitely want to have that low quality rendition, super low bit rate or low frame rate, or perhaps even audio only. So perhaps not a great experience, but I had a really great anecdote relayed to me by someone that was involved in the live streaming for the Olympics, and he basically said, if the client is getting stalls or interruptions in their stream, they're going to blame the stream operator. They're going to blame us. But if they're getting a low quality stream that's sort of pushing through, but maybe doesn't look the best, they tend to blame their ISP or their local connectivity. So take that as you will, but that was his feedback based on his experience streaming the Olympics. So you want it to sort of work. You want a signal path to come through, even if it's not the best, rather than it just stalling out and buffering and getting a ton of complaints online. And finally, of course, if we want this thing to scale, we're going to be dealing with content delivery networks, so we need to sort of set the right signals and hints for those downstream CDNs that are going to actually deliver the content to the end users. So we want to make sure that we're setting appropriately setting the cache control headers, basically saying how long we want the playlist, the manifest, and the segments to be cached. And we're really trying to strike a balance between, increasing cacheability, making sure as much of the content is actually delivered by the edge as possible, versus, not wanting to serve up stale content, stale playlists, and so on. So typically we might use, a lifetime of 1 second for a manifest and maybe a minute for a segment. And we just want to avoid any sort of repeat or old or stale content being served out of the cache. And of course, sometimes you get some dumb encoders out there where if you have an interruption and the encoder restarts, it can start serving up, or at least using or reusing numbering on your segments, and potentially have the issue of serving up stale content. So we want to use a unique naming scheme, maybe based on the time code of the signal coming in, to make sure that that's unique, that's always increasing, that there's no danger of old or stale content being served up. So now we've got our origin, it's doing our packetizing and our transcoding, and it's acting as an origin server for our CDN layer before ultimate delivery to those end users. So using a single CDN is an absolute recipe for failure. If it hasn't blown up in your face before, it will, I guarantee it, because there's some great CDNs out there, but they all go down at one time or another. We work with pretty much most of the major CDNs, seen outages on all of them. None of them are perfect. And if you assume that they might go down, you're going to be in a better place if you can, expect that they're going to fail and have a contingency plan in the event that they do. So we had a major event last year where our primary CDN went down about 15 minutes before the event. So this was an event where we were expecting, global viewership, 1 million concurrents, all ready and waiting to watch this really exciting piece of content. So again, I'm not going to name names. There's no need to name names, but because they do all go down. But thankfully, so we had their texts, giving us feedback before the event. But we couldn't quite, track down the issue before the event started. So thankfully, we had 3 backup CDNs, and we were able to switch those in right before the event, and basically avoid any major issues in streaming that particular event. So it went with that issue. We went with our backup CDNs. It went seamlessly. We had nearly 1 million concurrents, and we got a post-mortem from the primary CDN about a week later. So it didn't really help us in the day, but we were prepared. We had the backups in place, and we were able to switch those backups in with a really short notice. So so there's a lot of multi-CDN offerings out there right now. If you're of a certain size, you can try and manage it yourself. If you've got the contracts with the multiple CDNs, you can use a provider like Dyn or Sidexis that have multi-CDN management products that work at the DNS layer. If you don't want to manage them yourself, there's of course providers that will offer an aggregated and optimized and managed multi-CDN service. We are one of them. Of course, there's others.
Like Meta or Streamshark?
Like Streamshark,
Yeah.
perhaps. But of course, there's other players out there that offer an all-in-one managed multi-CDN streaming solution as well. So if you don't want to do it yourself, there are folks out there that can offer you a managed service as well. So the other big sort of question you need to ask before running a major event is, where is your audience going to be? So we're certainly spoilt for choice in terms of capacity, points of presence and so on in North America and Europe. But if you're running the event in perhaps a more far-flung region, maybe in China, Middle East, India, for instance, it is worth asking the question of your CDN, what is your capacity in that region? How many POPs do you have in that region? What's the maximum egress? And you might sometimes be surprised at the answer if you're expecting a very large cohort of folks in those regions to access the content. So again, there's definitely value in a multi-CDN strategy to service those interesting regions. And when you talk to these different CDN providers, they do definitely have competencies in different regions. So North America and Europe, well covered, but there are sort of specialty CDNs that handle traffic in China, for instance, or India, and have sort of points of presence in places where most of the other mainstream CDNs don't, like across the Middle East as well. So it's definitely worth talking to your CDN and making sure that they've got the capacity in the places that you need them to be. And of course, just word them up if you're expecting a big surge of traffic in one particular region, and make sure that they're comfortable with the traffic levels you're pushing there. And finally, when going with a multi-CDN strategy, you can have the issue where your origin server gets absolutely smashed. So if you're working with 3 or 4 different CDNs, potentially hundreds of edge nodes trying to access the content at the same time, if you're not careful, you can very quickly overrun your origin server and basically, load it up to such an extent that it can't actually service these end user requests that are coming in. So there's the concept of the origin shield that you can deploy in front of your origin service to make sure that they're not totally overloaded by traffic, and it's essentially like an intermediate layer that's going to coordinate, receive these requests from all these different edges, and basically be a single point of contact for your origin to actually, schedule these requests, schedule repeat requests, and hold copies of content that many people are asking for at the same time. So it's a great strategy to protect your origin servers and make sure that there's no interruptions to your stream. So a lot of CDNs actually offer this. They can offer an origin shield service to sit in front of their network, or you can roll something yourself if you've got a competent technical team and you're comfortable with running Varnish or Nginx or another caching layer that you want to deploy between your CDNs and your ingests. Okay, so this is obviously super timely based on what happened a week or two ago. So I'd wager a lot of folks didn't know or care much about DNS a couple of weeks ago, probably especially in the streaming world. But yeah, obviously there was a very, very major distributed denial of service attack on the 21st of October. It brought down or certainly reduced the functionality of one of the major DNS providers out there, Dyn, who services a lot of big name clients like HBO, New York Times, Netflix, Amazon.com, and so on. So a lot of high profile websites were affected by this and perhaps didn't have a strategy in place to deal with the loss of their primary name server provider. So that was obviously not great. That happened throughout the 21st of October, predominantly on the East Coast, and a whole lot of folks had issues throughout that entire day accessing content from those big name websites that use Dyn. So they're escalating, they're happening all the time. DNS providers deal with these sort of attacks on a daily basis, but this one was obviously particularly extreme and actually caused a pretty major loss of service. So choose your primary DNS wisely. Like certainly, 2 or 3 weeks ago, I would have said if money was no object and you just wanted a single DNS provider, like go with Dyn. They haven't had an outage in over a decade, up until about a week or two ago. So certainly they're one of the best of the best, but even they weren't immune to an attack of this scale. So a lot of folks rightfully are talking about, what's a redundant strategy that I have now? How can I make sure that if my primary DNS goes down, I'm not totally out of service so people can't access my website, my video players, my streaming applications? So this is where you want to look into a redundant DNS strategy. If you've got simple DNS setup that doesn't change much, it's really easy to just export your settings from your primary provider, import them into a second provider, update your naming server entries, and then you've got a level of coverage there in the event that your primary provider is being overwhelmed and not answering requests for folks trying to access your website or your stream. If you've got a bit of a more sophisticated setup where you may be adding new domain names all the time, there are some automated approaches. You can set up a sort of a primary backup system where the backup's polling regularly for any new names that might be created and is adding those entries for you. If you're doing really super sophisticated traffic management with your DNS, you're going to really have to take more of a hands-on role in managing this approach and managing the implementation of this approach. So if you've got Traffic Manager on, say, Dyn, you basically need to find an equivalent sort of Traffic Manager solution on your backup provider, use perhaps their APIs to create the primary setup and create your backup setup with more or less the same type of logic, business logic and load balancing logic, and run them both together at the same time in what's called a dual primary mode. And that way, either of those DNS providers can answer DNS requests, and basically whoever answers the fastest is going to return the results. So it's a pretty great, if you've got the resources, it's definitely a great way to make sure you're not going to be affected by DDoSs or any sort of outage with your DNS provider. So hopefully it's front of mind for folks now. So for you, if you're a streaming provider and you want to do it yourself, or if you're using a streaming provider, ask them the question, ask them what is your DNS strategy and how you're going to deal with issues like this. Okay, and finally, let's talk about the playback and the playout aspect of the system, and what sort of steps we can take to make sure that we have uninterrupted, reliable playback. So, of course, we're using HLS and Dash protocols to do our streaming to different devices. Both of them have sort of rudimentary failover support built into the protocol. So if you're on Dash, it's got this base URL concept where you can put that in your playlist, have your primary server, your backup server, as many backups as you like, and as long as the client can understand that and do something with that information, it can actually fail over at the client level to make sure that streaming is playing back in an uninterrupted fashion. HLS has something similar. It has the concept of redundant streams in your master manifest. So you can again set your primary and your backup for every quality level that you have in your stream to make sure that in the event that the primary is down, the client is hopefully smart enough to pick up that backup and start streaming with that. It's the sort of support for this feature is a bit variable. It's supported sort of on iOS. Not all client engines or playback engines actually support this functionality, so you might find it's a better strategy to actually implement this in your own player yourself. So we're depending on the player to actually do something useful with this information, but it doesn't always do that. So at Streamshark, we've actually had good success with just creating our own sort of load balancing and failover logic, having a list of potential candidate URLs for the content that might be on different servers or different CDNs. And then in the event of an issue, we intercept that issue and then try one of the backup streams to make sure that playback is totally seamless and not interrupted. And we found that approach to be quite effective. We just have a really simple polling approach where every 5 seconds we just ask our service to say, hey, what are the candidate URLs we can use? We can insert new sources for backups. We can take them out if they're not working and so on. And it's quite an effective way to get a reliable stream. So yeah, we do find that to be a job better done at the client level rather than the DNS level. There's an inherent delay with DNS in terms of trying to do load balancing and propagating any changes. So we find that the client's got the best view. If they've got a localized issue that maybe isn't seen globally by our monitoring systems, they've still got choices in terms of playing back the content and making sure there's no interruptions. And of course, if you're using a hosted player vendor and a hosted streaming provider, you should be asking them these questions. Say, what is your CDN strategy? Do you use one CDN or many CDNs? And what's your DNS strategy? Do you have failover? Do you have a protocol in place to deal with these sorts of issues that could totally knock us off the internet and stop our streams from being delivered? All right, I'm going to throw it back to Eric. He's going to talk about Facebook Live.
I'm going to talk about lots of stuff. Hey, it's good to be back, guys. There's lots of places you can push to when you're live streaming. there's a lot of, this is sort of reiterating what I said at the beginning, like there are some really good reasons to go live, and there are reasons that make live content more compelling than VOD content for certain aspects, and that's live sports, breaking news, watermelons, and interactivity. Or like the phone, which is like an authentic look at something you wouldn't normally see, which is like a celebrity, like watching Vin Diesel work out at the gym. Like that's a great time to use a phone. Or the Rock work out at the gym. That's all I see on Facebook Live, I think, is Vin Diesel and the Rock. Yeah, so wherever you're going, whatever the place you're pushing your streams to, whether you're hosting your own live streams and have your own player, or you're pushing to something like Facebook Live or YouTube Live or Periscope or any of the, or Twitch, or there's other one, Ustream, Livestream, Grabio, wherever you're pushing. One thing to really think about is like what makes this content good for live? Like why does this have to be live? And I think that's one thing, like right now I'm seeing a lot is we get all these requests like, hey, we want to do a live stream of a guy on a stage talking. And it's like, this right now, what we're doing, this would suck on a live stream. Like you'd see it in your feed and you'd be like, it's just a guy standing on a stage talking. I don't really want to watch that. Great for VOD because you can search out this content and you'll be like, oh, I want to learn more about reliable live streaming and all the different things that can go wrong, and I want to be terrified every time I go live. And you can find that as a VOD, and that's a much lower risk. If there are failures, if something bad happened in this room, we could take the VOD, we could cut out the bad parts, and we could put it back up. If uploads fail, no one knows except you. You can go and upload it again. When live streams fail, they fail big, and every single person watching sees that failure, and that's what they're going to talk about. So I don't know if you guys remember the Apple WWDC stream that failed pretty miserably, and then they had like the Chinese language version that played over the English version for a while. But after that live stream, people didn't talk about the new products. Like I have no idea what Apple released at that live stream, but I remember the live stream failing. So make sure you have a really compelling reason to go live versus just posting a VOD somewhere. I know it's not popular, like live is, everyone wants to go live right now, and there are lots of good reasons to do it, but just really think creatively about like what is that thing in your event that's gonna make it a good live stream? What's gonna drive people to your content? What's gonna make it so that people really wanna show up? And there are three things plus the watermelon, which is sports, breaking news, and interactivity. And it's probably gonna be interactivity if you're not live streaming sports or the news. So think about how to make it interactive. Think about how to make it fun. Then we're going to talk about some best practices for Facebook Live specifically, because I work at Facebook. So.
Okay. You want to do it? Or?
No, you go.
I got it. All right. Yeah, just a couple of best practices for Facebook Live. So obviously, it's blowing up. I can say nice things about it.
Yeah.
It's hugely popular. You know, great way to reach a huge audience natively. But there's a couple of sort of caveats and best practices you can follow to make sure that you get a really good signal into the Facebook Live sort of workflow and API system. So based on what we've just said for the last half an hour, please, you know, even though you can just pull out a phone and do a Facebook live stream, it doesn't mean that's a great idea, especially if this is something really meaningful to you, if there's a real risk of failure and if there's consequences if there is failure. So if that's okay, then by all means use a phone, but otherwise treat this like any other professional streaming system and make sure that you're pushing, you know, you've got a good workflow there and you're pushing in a high quality stream.
Yeah, I think with the phone, one thing that is helpful for me to think about is like the phone has a low barrier to entry. Everyone can do it. That also means it has a very low barrier to failure, which is okay with the phone because people see it and they have that sort of expectation, like, oh, it's a phone stream. If it messes up, whatever. But as soon as you go into the live production stuff, that's really when you want to dial up everything.
So if it's the president doing an announcement, you don't want that to fail.
Yeah.
So, you know, all the same caveats applied to streaming to Facebook Live. Also, just a few other points, like be on the money with your stream stopping and starting. So basically, as soon as you hit go live on that Facebook live stream, that's pushing out to Facebook, to the page or the profile that you're streaming to, and that's what's going to get archived. So make sure that you're on the money with the start of your stream because it's going to get packaged up into VOD after the fact, and people are going to see that on their timeline. And if it's just a 5-minute preamble where people are playing with the lights and testing the mic levels, you're not going to get great viewership of that VOD. So
Practice ahead of time.
Practice ahead of time.
Start a lot of streams.
Start a lot of private streams to your own pages.
Have a clock so you know exactly how long it takes you.
But the preview function is super helpful in this case. So you can sort of set up the stream ahead of time. You can start pushing to it without it displaying necessarily any picture or content on the page or the profile that you're streaming to. And then you can sort of get your timing right on the preview stream and know when you need to go live. The preview stream is RTMP, so it's actually fairly low latency, which means you can time with a reasonable degree of accuracy, when the event is about to start, when the talent is about to walk on the stage, and get your mark spot on. The same is true. Make sure you, I'm just skipping ahead a bit here, but make sure you end it cleanly as well. So there's you stop streaming. There is this notion of it's the terminology I think is called sealing the stream. So once your stream is done, you need to close it out properly. Otherwise, your users are just going to see a bit of buffering for about 3 minutes, and that's like the timeout level of it deciding that the stream is finished because you stop pushing to it.
Don't end it too early either.
And don't end it too early.
Give it a little extra time on the back end.
Yeah. And send in the best possible representation or contribution of your stream. So there are some limitations about what you can push in. Previously, it was 720p, 2500 kilobits per second. They've bumped that up to 4000 kilobits per second, which has improved things somewhat. With a 2-second keyframe. So that's what they're expecting. If you can send in that version of the stream, you're going to get the best possible rendition out the other end once it goes through the Facebook Live API workflow. If you have any issues, if there is any sort of disconnect in any part of your workflow while your stream is active, you've got 3 minutes to sort that out. So if you're in the middle of a high-profile live stream, if something happens, your primary uplink goes down, you've got 3 minutes to basically get a new signal into that same destination that you've set up before Facebook API basically marks that stream as done and the stream is over. So there's no sort of concept of primary backup right now. Hopefully that'll happen in due time. But for now, we do something we call stream juggling, where we have a primary setup, we have a backup setup, so that exact same workflow that we've been talking about. And we're sort of ready to go in the event of an issue with our primary path, and then we can start pushing to Facebook from our backup path manually, a little bit manually, but that's one way to sort of get a bit of redundancy in the current Facebook Live workflow. And I've already spoke about cleanly ending your stream, so same principle applies, just be on the money with the start and the stop. You'll get a nice, nicely topped and tailed VOD at the end of that, and hopefully get a lot of views after the fact once your event is over.
Yeah, just to close out, the one thing I would say, and this goes for all live streaming, not just Facebook Live, but like at the beginning I said, like be terrified whenever you have to go live. Like it's really scary and you should feel scared, but also use that terror and the sleepless nights, like use that to really think and be paranoid and go over in your head over and over again every single thing that can go wrong and work to mitigate all those things ahead of time. Because it is like, all of these scary things and all the things that can fail can all be mitigated to a sense. Like if you're live streaming, you will fail. And a lot of times it takes that failure to actually like learn how to do it better. But if you are really, really afraid of it failing and you really push to like figure out all the things that can go wrong, and you practice and you test and you think about all these things and you build backups and redundancies and mitigation for all that stuff, you're a lot more likely to have a successful live stream and not get fired at the end of the day. So, yeah, That's it. That is all we had prepared. So we could take questions, or if you guys want to hear stories about massive failures we've had,
I was actually hoping to hear stories
if you
from
guys
you
have
guys.
stories of massive failures.
If you've got an epic fail story, we'd love to hear it. Or any questions,
Yeah.
So we're using a multi-CDN strategy, but we're having to do the switching on the front end because we actually want to include multiple players in our redundant strategy. And so I'm just wondering if you're aware of any off-the-shelf solutions or any companies that are doing that, so we have to do less of a manual effort on our end to actually switch multiple players.
So when you say front end, do you mean you're doing it at the client or with a load balancer? On the web page.
Make sure you repeat the question.
Yeah, sorry. So the question there was, hopefully I'm getting this correct. So you are using a multi-CDN strategy, but you're having to do a lot of manual work in terms of rendering the correct player for a given feed.
So we have 3 CDNs and 3 players. And then we get a player to the CDN.
Oh, okay. Yeah, I mean, not to plug us too much, but that's certainly something we do. So there are ways to handle that. We take, I guess, a multi-tiered strategy, or you could do this yourself. So we can, there's a high-level mapping at the DNS level where we have, multiple CDNs deployed. They're all sort of fronted by a DNS name, a CNAME, and we can do some balancing and distribution between those CDNs. But we also, at the client level, have a list of manifests that could be, CDN1, CDN2, CDN3. They're in the one player. So you can put some smarts in there to say, well, I can't access CDN1. I'm going to try my next one in the list or the next one in the list until you've got a signal going. So that's some sort of custom, client-side stuff that we've done at the Playback engine level on a web-based player. So yeah, it's definitely doable.
It's also having the multiple manifests in a single player means that you can dynamically switch out what manifests are in there. So if you had like a CDN that started throwing 400 errors at in the last 15 minutes, you could take their manifest out of your player and replace it with a different one.
That's right. So I mean, you can both catch the 404s and try an alternate. And then if
you catch it ahead of time, you can swap
if we can see that at the sort of top level as the stream operator, we can just take them out of the list. So people aren't, if the primary is always failing, we don't want the new guy to load the primary and fail and then fail over to the backup. So there's techniques we can do there. And I think I mentioned in one of the slides, there's some rudimentary support at the protocol level where you can list out multiple CDN URLs with your primary and your backup. And depending on the device, it could do some basic failover where if the first one's not working, I'll try the second, I'll try the third. So there's definitely, there's techniques there. You shouldn't need to have multiple players to achieve that.
What do you use to monitor that the live streaming working properly on the client side?
So the question is, what do you use to monitor? James, what do you use to monitor that the live stream is working on the client side?
Sure. So we use a combination of, we do your typical synthetic type tracking of the feeds. So they're just probes out there on the net. They're not necessarily end users. And that gives us more of a top level view of the health of the different CDNs. But then, at the client side, there's some sort of RUMs, real user monitoring / RealTime Stats that runs in the player that's actually picking up any sort of errors, 404s, 500s, 501s, the whole, whatever you class as an error, that's being monitored in the player and then being reported back centrally to it. It's a sort of a dashboard where, you both get the report on what happened, but there's also the logic in there to work around any of those sort of error conditions actually happening.
That stuff's nice to have too, because then you get QoE metrics at the end of the day. So you can say, this is how many rebuffers we had, this is what quality, this is how many people got the HD stream, this is how many people didn't get a stream at all, those kinds of things. So it's nice to have.
Hey, I work with EPG, offer caption streaming solutions, and we get a lot of people coming to us, they want to do streaming to big browser, YouTube, it's fine. They want to do Facebook Live. We're unable to do that because Facebook doesn't support captions. So I was wondering if, since it is such a major part of streaming a major live event, does Facebook have any plans to support captioning in the near future?
So I'm not directly involved with the future roadmap of Facebook Live. It's definitely an important thing. So if anyone was in the live video industry, I would think they'd be thinking about it right now.
Yeah.
But it's not there right now. You can upload SRT files afterwards to have it for the VODs, and that way, So the VOD, you can add them. You can add captions afterwards. It's definitely something that's really important. I don't know that I can say more than that. But keep an eye out. It's changed a lot. The product, Facebook Live has only been a product for less than a year.
Yep.
like 6 months if you talk about like the live API and being able to do like real streaming outside of the phone. So, and it's like in that time we've like increased quality, we've increased reliability. There's been a lot of great, like really big upgrades to the system throughout that time, and those upgrades will continue as the product matures.
Yeah, since it came out, I mean, there's just been an influx of questions, so it's,
Yeah. Yeah, it's really popular right now, and it's like, it's important to us. We want to get it right, so.
Hi, I'm Tarek from Twitch.
Hi.
My question is, you recommend contribution fee to be 4 megas per second.
Yeah.
Are you necessarily going to transcode that or just transmax it and send it back to the customer? That's my first question. And my second one is, the flood you provide, is it another way transcode or just a capture of what you have provided now as the quality could be fair?
The VOD is based on the live stream that you put your contribution in code.
A capture of that stream.
Yeah. Yeah, it goes, I believe it goes through the same process as, I don't know why I'm looking at you, you don't know.
I mean, I use it, so that's my understanding.
Yeah, it goes through the same, basically the same pipeline that a normal video upload would go through. So it gets transcoded from that 4 megabit stream, and we do multiple versions of it and everything.
Why don't you recommend doing a higher rate, like 10 megas?
We don't ingest that. It won't on the live streams.
Platform image.
Yeah.
What platform do you use for transcoding? Is it your own build or
Yeah.
hardware or something?
Don't look at me.
I don't. I don't know if I can talk about what we're doing on the inside. Sorry.
What lengths of live streaming do you see? I mean, how long is it? Do you see like normal, high, low, and then my other question would be, do you see a difference on depending on what platform, like whether it's a mobile or?
Yeah, mobile streams tend to be shorter because a lot of the time is someone like holding a stream up. So you'll see like 4-minute live streams, which is like really too short to even build an audience, but it turns into a VOD. It shows up in people's feeds and they watch it because it's usually pretty interesting content. For the longer ones, you'll see anything from like 45 minutes to 4 hours. 4 hours is our limit on the platform right now. And then we also have something called continuous streaming, which doesn't generate a VOD, but you can do like puppy cams and stuff that way. So we have like streams that have been running for weeks.
The ambient streams.
Yeah, ambient streams. Is that what, not
That's what it's
continuous,
called.
ambient streams. And those are fine. They get pretty good viewership for some of them. And
Yeah, I don't think the discoverability of the really long streams is as good, but yeah, the capability is there if you want it.
Yeah. But yeah, I mean, like if someone's at an event live streaming, talks are usually an hour, so the streams are usually an hour. It's really dictated by what the content is. And we've had other people they'll do like sort of podcast style live streams where they're talking about sports or games or stuff like that, and those will go on and push like that towards that 4-hour limit.
Yep.
So just really dependent on content.
Outside of Facebook, you mentioned in some of the architecture slides having redundant origin / potentially edge transcoding, packaging, that kind of stuff. Is there a platform, if you try to roll your own solution for that, is there a platform you kind of nudge people towards? Like we use Wowza, but there's some limitations there with redundancy and Dash and stuff.
Yeah. Yeah, I mean, Wowza is an option. It works well for HLS. I don't know that it can, I know that they were working on this, that in terms of having identical renditions coming into different servers. So maybe, I think if that's not happening already, that's going to happen soon. So that's an option. You can sort of use it as a bit of like
Is anyone from Wowza in the room?
Yeah.
They're here.
Yeah, I know. You look for their own shirts. But yeah, we've used Wowza a lot in some of our pipelines. There's Nginx RTMP as well. Like if you want to hack on it, you definitely need to know your stuff. You need to know your C because it's sort of, I would call it slightly unmaintained at the moment. So if you've got some chops, you can leverage
It's
Nginx.
a cool project.
It's a great project.
Open source and free.
It's an amazing bit of code, hugely powerful, but yeah, quite complex as well. So there's a few options there, both paid and not paid, where you can
paid for in blood, sweat, and tears.
Yeah, where you can basically set up a redundant sort of origin strategy, and there's application level load balancers. You can use HA proxy in front of them. You could use a DNS load balancer. Like, there's quite a few approaches you can use there to affect something like what we've spoken about. So if you've got the means and the resources, like it's all very doable.
Or use Streamshark.
Or use Streamshark. But yeah, the pieces are there, and there's some good sort of, I guess, documentation and learnings out there where you can see how other folks have done it and have implemented sort of really robust strategies and implemented systems that stream at massive scale. Yep.
Yeah, what's the best way to achieve keyframe alignment, primary and secondary streams from
The question, we've forgotten to
sorry,
say the
I should be
question.
repeating.
Sorry, sorry guys who watch this in the future.
So what's the best way to achieve keyframe alignment with your contribution stream? I mean, a lot of platforms will support this. Like, we said don't use software, but Wirecast, for instance, can push keyframe aligned streams to multiple destinations. You can do the same. One Wirecast, of course, that's not great. But Elementals can do the same. You can get timecode and keyframe aligned streams from multiple Elementals and push that in there. There's solutions sort of in the mid-tier like Zixi that I know can do that and do some creative stuff with I guess, synchronized clocks and recoding your stream as it comes in. So there's a couple of sort of software and hardware solutions that can do that. So I'd say it's non-trivial, but once you get it set up.
If you've ever tried to work with timecode, it's non-trivial. That stuff is...
Yeah, of course, you'll probably want an SDI input, not a HDMI input. It's non-trivial, but worth your while to invest the time into getting a workflow that does that.
I think...
Next question, how important is this? Like, for example, it's not aligned.
Look, it's not the end of the world, but like if you had to...
If you want seamless failover, it's important.
Yeah, if
you're okay with a hiccup.
Yeah, exactly. That's exactly what I would say. If you're happy with a bit of a jump or a bit of weirdness for maybe a second or two in your stream as it cuts over to the
GOP length.
Yeah, as it cuts over to the backup, then look, you can get away with it. But if your mandate is the stream can't fail, it has to be perfect, it has to be seamless, then you need to go the extra mile and make sure that your different contribution streams are aligned. Yep. Sorry.
Two-part question. You mentioned before that you've done the redundancy using Wowza. That's been on two separate servers and two different locations. Now, when you had that failure, when you had one fail, how did you make it seamless to the next one?
Yep. Yeah, so you...
Remember to repeat the question.
Yeah, so if you've got two origins, different locations, perhaps running Wowza with your timecode aligned signal in there, how do we actually make it seamless when we fail over from a primary to a backup? So I guess there's a few ways to do it. One is not seamless. It's basically just, you start getting 404s and then it says enough is enough. And it starts loading content from the backup manifest. And that's more of a, the stream plays, you get a bit of buffering for maybe a second or two. We decide this primary is not working anymore, and then we cut over to the backup stream. The alternative is you basically need to get into the client playback engine, essentially, into the fragment or the segment loader, and basically have it such that it's looking ahead. It's looking ahead in the manifest. You've got a manifest with 10 segments in it, and we're playing from the top. And then I can see, towards the end of that manifest, I'm not accessing these segments anymore, to actually go straight to the backup then and start pulling in my segments from the backup rather than the primary. And that way, I'm looking ahead, I'm pulling in the segments because I can't get it from my primary, and by the time I get to that part of the window of the playlist, I've got the segments from the backup and the play out is seamless. So again, not trivial, but it's doable. We use, for instance, HLS.js, where you can sort of get into the internals of the playback engine and actually change how it sort of the policy, I suppose, of it, how it asks for segments and how far it looks ahead and what its sort of threshold is for failure before it tries to do something else. So it's really getting into the guts and coming up with your own sort of solution to work around that problem.
Yeah. The short answer is have a player with really good logic in it.
Yes. Yep.
Like the Streamshark player.
But that's how you would do it if you wanted to do it yourself. You basically got to hack the player.
It's kind of continuation of this question, but what's typical logic behind primary and secondary ingest points? Like how do they decide to switch between each other?
On the ingest?
On ingest
I mean,
I think I don't. Oh, well, so the question is same question, but for ingest rather than playback. I think you'll see that error happen in playback, and the player can make that decision. So you like, just let the player do the failover for you.
yeah,
Okay, so you basically continue like ingest points.
yeah.
I mean,
Try to push.
you could.
Yeah,
you could-
keep pushing, keep trying. So I definitely favor a client-driven logic rather than DNS-driven. Like we sort of do a bit of both, but
Yeah.
we tend to just say, well, if it's failed, it's failed. I'm depending on the client to figure that out, to realize I'm not getting the segments anymore.
That you
Yeah.
can also do. You could do more stuff on the ingest where you're like looking at bit rates and stuff, and you can actually like dynamically adjust your encoding based on network conditions
Yep.
and things like that. And if you want to implement all of that stuff, that's like pretty new and pretty
That's probably another talk.
technical and
But
very
there's
fun
definitely
and
clever
interesting.
things on the contribution side and the uplink side that tries to work around a lot of those issues and make that sort of seamless before it even gets to the ingest.
But
Yeah.
the client should be able to do it as well.
Yeah.
Just a small comment on that. Probably for the ingest failure, probably don't want to wait till the client because that is a long time for the retranscoding, the packaging, and for the delivery, which means you're going to lose probably a segment or two, which is 4 seconds or even more. But if you detect on the ingest side, that's probably better. And that's the reason you want to have the key align frame at the ingest side as well.
Right.
Otherwise, you can have an offline content for a second.
Yeah.
1 second.
Yeah. Yeah.
I agree.
Yeah.
Coming back to the player side.
Sure.
On live, you've got maybe a 10-second buffer.
Mhm.
So have you had in your experience a situation where, well, you run out of buffer because there's not enough source data coming in,
Yeah.
and so even the primary and the backup doesn't switch over seamlessly?
Yeah, of course.
Where should you be using
That can happen, and yeah. I mean, you're not limited to a primary and a backup. It can be n backups. So yeah, I will repeat the question. So I think you're saying that what's the issue where you might have maybe a longer segment length, maybe 10 seconds, and the switchover is not fast enough,
or you don't detect it?
or you don't detect it fast enough. Yeah, and there's definitely, on a lot of these HLS clients, you can sort of tune, I guess, how aggressive it is as well in terms of like, the trade-off between, I want maximum reliability, so I'm going to sort of start reading from pretty far back in the window. If real time is here, I'm here, and I'm sort of reading from there, reading my segments, versus, I want to get as close to the bone as possible. But, there's a greater risk of me asking for a segment that it's not there yet, or it hasn't been transmitted yet from the origin. So that's all tunable generally. And the segment size is tunable, the playlist length is tunable, and it's just about coming up with the right mix for your application and I guess the demands of the users. So
Yeah. Hopefully you catch that during like the rigorous testing you're doing before
Yes.
your event, rather than during the event. Because like if you're live and you start noticing that that's happening, it's too late to make any changes that would fix that.
it's tough. It's really tough.
But so do a lot of testing early. Find out how that happens, like test failover, like that's a really important one. I don't know how I forgot to mention that,
Yeah,
but
we
like
did mention
one
that.
of the biggest things that we do is we test every step of our signal path failing for every single live, because every live is a little different. Every live uses a slightly different, there's no like playbook that we go to and we're like, we're live in New York or Italy or Africa, like every single one we use a slightly different solution. So like test every aspect of that failing. So test like turn off your encoder, like pull the plug out of your encoder to simulate like a power outage. Kill your satellite connection. See how each of those plays and what the delay is in failover and if that causes any problems, and then tune your system accordingly to the results of that testing.
So we've been towing, getting the quick tow in the water with base live, and we come from a place where we know we have the luxury of the infrastructure, the end-to-end ingest, CDN, and we have a view of that. What are your recommendations when we have those failure scenarios sorted out, testing for black box services like Facebook? How do you approach?
Just trust us.
I don't know who should answer that, but so we're sort of an API, a Facebook Live API partner, and obviously Eric is from Facebook, so I have a view, and I don't know how much Eric can say, but I guess, yeah, it is a black box, so it's just being aware of its capabilities and its caveats. I would say I don't know that there's a lot more you can do, and I don't know how much Facebook would probably tell you about the underlying infrastructure, but certainly, you know, the best practices for contributing to Facebook Live are quite well documented, so you can have, you know, a lot of success if you follow the guidelines. I think it's I don't know how much more I can say than that, but you know, it's a platform and has its strengths. It's sort of one of many places you can push to, and I think if you play to its strengths, but have a backup as well, you know, maybe an external player as well, you know, you're covering
ready to post a VOD right after.
Covering your bases, yeah.
I don't know that I have a great answer for that.
Yeah. And maybe I'll
it is a big black box. Like you look at, you're like, like you gave me a RTMP endpoint, I'm gonna push to that, and then it's out of my hands. Like,
but
so test a lot, like see what works, play with your settings. You know, yeah, and certainly when we run events for clients, we'll often have our white label Streamshark player as well as the Facebook Live player. So you've got, you know, some options there, you know, depending on the destination. So you might want to go natively live on Facebook because you've got that reach and you've got that audience, but you might want to use our external embed for, you know, to embed on TechCrunch or some other place. So at least in that case, you're covering your bases, you've got the right tools for the right job, and you know, you've gone in a bit of a multi-pronged strategy in the event of anything actually happening. So I think that's probably all we have time for. I don't want to hold people up from the beers. Yeah,
so
beer time. Yeah.
Thank you so much.
Thanks for coming, guys. Yeah.